Let's talk about applications for marginals and derivatives. Here we have three functions we already learned. One is the revenue function and the cost function, profit function. We know the profit is the difference of the revenue and the cost, incoming minus the cost. Here in the demand function, the price per unit is a function. We could call dynamic price. The price changes based on the demand, the product amount. Revenue function is the price per unit times the number of units. Marginal revenue. So the symbol is MR, the marginal revenue function. You add a bar and is a derivative. R prime. Now let's see this example. So the given price per unit is this linear function. So we know the revenue function R of X is the price per unit times the number of units. So is this 16 minus 0.02x times x. Then you distribute x to both terms, remove the parentheses, open up. Or you could have one more step. You line up based on the order. So we put the quadratic term, the square, this term first. So this revenue function is a quadratic function. Find the marginal revenue for the product at x equals 40. So first we see the keyword. We need to get to the R prime because this marginal means the derivative, means this prime. And we copy this function here. We know this based on the power rule, the 2 jump down is negative 0.04 because 2 times 0.02. Then this here downside is 1, so 2 minus 1 is 1. Then plus, we here use the additional rule, then 16. Apply the power rule again, we get a 16. So when x equals 40, you just replace x by 40. So we get 14.4. That means when we produce one more unit, suppose from 40 units, add one more, so go to 41. The cost will increase about $14.4. So for each unit. Okay, let's see the graphs for the revenue function and its corresponding this marginal revenue function is just a derivative. Because this revenue function is a quadratic function, we already learned here the coefficient of the x squared, a is negative 0.02 less than 0. So the graph opens down. We have a vertex, right? It maximum. So you see the vertex is here. We see here is the graph increasing, decreasing. When this increasing, we know the slope of the tangent line at each point. The trace along this curve, the slope always greater than 0. You see here is 400. So that all greater than 0 above this x-axis. Then we reach the 400 units, then the decreasing. You see here, the slope of each the tangent line at each point is negative. So positive, slope negative, so here. Then what's this? This point is matching this vertex. So vertex, the tangent line is horizontally. So the slope is 0. That's why here is 0. We know the derivative, each point means the slope of the tangent line at each point. So suppose here, so like 250 here, right? So for this point, so this tangent line, the slope is this number here. This is the slope. Can we determine the number of units to be sold so that the revenue is at the maximum? So that means the vertex. How could we get the 400? Based on graph, we know it's 400. The vertex, the tangent line is horizontally. So the slope is 0. slope is 0, that means this is slope, right? So it's 0. So x is 400. Now let's move to the cost function. And the keyword is marginal. So this marginal cost function is mean the derivative of the cost function. So C prime of x, symbol MC, marginal cost, and then add the bar, is the marginal cost function. So this keyword matches this derivative. Let's see this example. So given cost function, then find the marginal. We see the keyword. So is C prime. Based on the power rule and the addition rule, we also apply the constant rule. So the number, the prime is 0. When x is 80, so the marginal cost, so you just replace x by 80. So 80 squared 80 minus 606 times 80 plus 32. I just directly put the answer here is 3.2. So that means when we have one more unit, so we have the 81st unit, the cost will increase by about $3.2. So that means 3.2, this cost is for per unit. Once you have one more unit, the cost will add up this $3.20. So the similarly C and B is the same, just change the number, right? Here is 200, so you C prime 200. You just replace here, right? X by 200. Then we get a 32. That means once you have one more unit, the cost would add $32. This is the graph for the cost function. That's for the related the derivative function. And you see the cost function here all increasing. Then you see the whole thing, right? Whole derivative function all above this x-axis, all greater than 0, all positive, because any point, if we get to the tangent line, you trace along the curve, you would get all this slope for those tangent line at each point positive, so greater than 0. So total cost can never be negative. Cost always greater or equal 0. And the total costs are always increasing. Now let's see the third question. When producing 50 items, what's the total cost? When x equals 50, so what's the cost function is here. It's given here, right? Okay, I just directly write down the answer, $34.75. Next question, for the cost of the producing the 51st item, we get the derivative. Now we go back, copy this marginal cost function. Let me write down here. When we have 50 units, what's the marginal cost? We get $9.50. Then when the 50 produce one more unit, right? So we have the 51st unit. The cost will increase around $9.50. Right? So that's the every unit cost. So same thing here, 81st. So we just get the product when we have 80 units. Get answer 3.2. So when we have 80 units, add one more to 81. Then the cost is increased by $3.2. But for the 50 to 51 is 9.5, so per unit. So it's less. Okay, now let's go to marginal profit. So because the keyword marginal profit, right? We know this is a derivative, P prime. And for this, given this profit function, what's the marginal profit? So P prime. When we see this square root, the radical, we always change it to exponent form. So we can use the power rule. 10x plus 1, then negative 1/2, then minus 2. When we have 15 units, P prime 15 is 0.5. When the product from 15 to add 1 more 16, so the profit would add up 0.5, 50 cents. For each unit, the profit will increase by around 50 cents.